Okay, hello everyone. In this video, I will explain lab 4. In the lab 4, we will doing the port level I/O protocol modify. The objective of this lab 4 is the first one is identify the default I/O protocol for port, and the second is select the appropriate I/O protocol. And the third one is we will modify which one that I/O protocol we change into the several I/O protocol. In here, the default I/O protocol is none without protocol, so you can read or write in I/O protocol with the signal. And the second one is using wire handshake protocol. It means that you need to wait until the I/O protocol ready. If it ready, you can send the data. If you use the input. And this lab, I will use the wire handshake because in this lab we will use 1.1 port as input or output. Okay, now I will explain first here. This is the default I/O protocol. In the blue one is only input 1 and input 2 is only input, but in the 3 this is input and output. In the blue one only input, but in the third one input also output. So we can change the direction of both these three input or these three port into wire handshake protocol. In this lab, we have four file in here. The first one is the C code in here. The C code only summing three input 1, input 2, and input 3. But in the input 3, in the last input, this port is not only input, but we put the data in this port, so it will be the input and output port. This is the input and output port. And also this is the I/O test in here. Test pen file. The test pen file is nearly same as the previous video in lab 3. We tested in 5 times The first one we tested with input A equal to 10. The second one is equal to 20. The third one, the IOC, input output C, is 30. And when they tested, we put the temporal the IOC data, this 30, into the temporary IOC. After it sum, after it the data is going to address IO, going to this function, the output will be stored in this variable IOC. And in the last, after show the result in here, we'll check the IOC is equal same as this data or not, and we add input A, B, and the IOC with 10. So this is 30. Now we add 30 with 10 and save again into IOC. If there is the 1, value, it will return 0. It means pass. And if there is the fault in here, 0, it will return 1 and that file. And the last one is the run address IO TCL file. In the TCL file, we set up the project, open at the IO at the C file, in the C file in here, add the test bin and set the top function. And the last one is set up the part in here, ceiling device part in here, and create the clock into 0.5 nanosecond. And the only comment in here is doing the C simulation. So to do this lab, you only need to open the command with this command prompt in here, command, and go to this folder, into this folder, cd, enter, give the command vts hls -f. Wait, what is the TCL file here? Run address underscore IO. Run underscore address underscore IO dot TCL. Press enter. Now doing the C simulation. Okay, the C simulation is passed in here, and I will open the UI. It is HLS minus. Oh wait, is it? Wait, see this HLS. Okay, you can open the project, this lab 4, and select the address IO project, select folder. Okay, this is the C simulation report in here. The C simulation report is passed. Now we will run the C synthesis here. Run the C synthesis. I will put the active. Okay. Run C simulation. Run C synthesis active solution. Here you can see in here in the C synthesis report, address IO report, in the interface. Okay, this one. In the interface, you can see that input 1 and input 2, the default is without the IO protocol in here, without IO protocol. But in input output 1, input output 1, the input output 1 here, input output 1 here, because one port become input and output, it will use APOVLD IO protocol. What is IO or VLD protocol? Here I can show you the explanation. IPOVLD, the use is for input and output argument. So the IO protocol, the IO port will be input and output argument. The port become the IO input and output. Not only input, not only output, but the port become input and output. If using the APVLD, APVLD is using a handshake protocol. So it only handshake protocol. Using a handshake protocol. Handshake protocol means there are three port include the input, and it will give you the signal in here. If the port is ready, so you can send the data and the FPGA will be read. This is for waiting VLD. If the port are ready, it give you signal in here and read. And then if the output using a VLD, it will give you a signal that the port or the data is ready. Okay, we will change all these port input 1 and input 2 in wait, we will change, okay, input 1 and input 2. Input 1 become VLD. Input 1, input 2 become the ACK, and the last one become a handshake. Okay, input 1 directive, input insert directive, input 1 direction file become interface, and the first one become the VLD. Okay, the second one become ACK, and the last one become AP handshake. Okay. So after done the configuration, now let's see. Let's see. Let's see into constraint. Let's see into constraint. Okay, they will add comment in here, constraint. Input 1 become the APVLD, input 2 become ACK, input 3, input output 1 become a handshake. And now we run using a C synthesize. Okay, the C synthesize is finished. Now look at the syn folder and report. Okay, you can see in the summary in here. Now we have input 1 have become a APVLD here. There are two port for input 1. The last one we only have this one, only have input 1 only, and without any protocol here. And now we have a input 1 and input 1 VLD port. This is scalar and only 1 bit. Input 1, it has 32 bit here. Input 2 have a 32 bit, but APACK 1 bit. This is output. Okay, now after we are doing the lab 4 in here, let's check and generate the signal in here. Doing co-simulation and dump trace all protocol, and okay. Okay, simulation, Verilog, we open with. Okay, let's check all I/O. Why is will pop up in here and look at all. Okay, you can see after we change in the input wire 2 and input wire 1, you can see if we are using the handshake protocol input and output, it will give you the signal in here. If it will give you the signal in here, because in the test, the in out is the input output, so it give you the high signal in IPVLD port, and we can send the data in here. The data will be processed in here, and after data send, wait a moment until it ready, send the data, and the output, it will be out in here. After they have a low output in here, they give you high again in here, input APVLD. After high, you can send the data again, and then after data is processed, it gives you high signal in here, and so the output is ready. After output is ready, they give signal IPVLD in here, and you can send the data again. So like this, this is the handshake protocol. Give the signal before send, and give the signal before the output is ready. You can see in the APACK is also like this, but APACK is for input, only input, and the validation, AP validation is only give the high. So give the high, if you give send high, always give send high, you can send the input data, but APACK give one moment signal in here. So after data is sent, it become low. It sequence like this. So this is the difference between APACK and IP validation. APACK is knowledge that your data has been sent, and IP validation give you the data that the input is ready. Okay. I think this is the end of lab 4. This is the end of the lab 4. You can try with different architecture in here and test the IO protocol in here. See you in the next video. Bye bye.